Humans are naturally obsessed by size. We're continually trying to find out how big or how small objects are, from tiny atoms to massive galaxies. Today I'm going to take you through two instruments we use in physics to help us improve the accuracy of our measurements. They are the caliper and the micrometer. How do they work? Let's start with the caliper. So the caliper works essentially like any regular ruler, but it has the benefit of being able to measure both external and internal distances. So if I want to measure the external diameter of this washer, I would take my washer and place it between these two teeth. Slide it along till it just touches, then tighten it to lock it in place. This is now the distance of my external diameter. If I wanted to measure the internal diameter of this washer, I would use these two teeth at the top here. Same thing. Place my washer between those two teeth, move it across, it just gently touches, take it away, lock it in place. This distance is now my internal diameter. So how do I read it? If we look along the main shaft, we see a series of large divisions which are in centimetres, and the smaller divisions being millimetres. What's really important though is along the sliding arm. Here the larger divisions are 0.1 of a millimetre, and all the smaller divisions along there are 0.02 of a millimetre. So how do I read it? First of all, on the sliding arm is a 0 mark. I need to see where the 0 mark falls between which 2 millimetre marks along my main shaft. Let's have a look. So I can see that this 0 mark is falling somewhere between 10 and 11 millimetres. Let's note that down. So to get the rest of the measurement, what I need to do is I need to look along my sliding arm and see which division along my sliding arm matches up perfectly with some division along the main shaft. So let's have a look. So if we see here, this is the mark of 0.3 of a millimetre. If I just come two smaller divisions across, that's the mark of 0.34. It lines up perfectly with a line somewhere above it on the actual shaft. So I take that value and add it to my lower. So the distance of this internal diameter is 10.34 millimetres. Highly accurate, but it has its limitations as it can only go to 0.02 of a millimetre. We can improve our accuracy by using a micrometer. This works a little bit differently. What we see here is a shaft and here is a spindle. As we turn the spindle, the shaft goes out or comes back in. Every full rotation of my spindle moves the shaft by a distance of 0.5 of a millimetre. If we look on the shaft, we see this horizontal line, which is where we read everything off. The vertical lines above that line are millimetre marks. The vertical lines below it are half millimetre marks. So to get our measurement, what we have to say is, what's our last millimetre mark? Do we see a half millimetre mark? And then simply add on whatever's left on the barrel. So if I want to measure the diameter of this ball bearing, I place it here in my micrometer, touch it just gently, and I can lock it into place there. So what I need to do is say, which millimetre mark can I see? Well, looking carefully, I can just see the 15 millimetre mark. But on the bottom line, I can see the half mark has come through. So I now know that the diameter of this ball is between 15.5 and 16 millimetres. Let's write that down. To get the last part of my measurement, all I do is say, where does the line match up with the measurement on the barrel? So you'll see here, it seems to line up with the value of 0.49. So I'm going to add this value onto my lower measurement. So that would mean the diameter of this ball would be 15.99 millimetres. Highly accurate. So let's just go over that one more time. With the caliper, We line up our 0 mark between which 2 millimeter marks. Then we see on our sliding arm which division lines up perfectly with some division above it on the main shaft. We add that on. With our caliper, we say, okay, do we see a millimeter mark? Do we see a ½ millimeter mark? And then just add on whatever's left. So I hope this helps you use these devices in doing your own accuracy measurements in physics. Good luck.